Okay, we're going to shift gears just a little bit. I know you've been graphing quadratics, but we're going to get into something called factoring. And factoring will lead back up to quadratics, but we need to go to the basics of it first before we get into the major factoring. Okay, so factoring. Factoring just means that you're finding numbers or variables, finding numbers or variables that divide evenly into another number. So you started learning this after you learned multiplication. So let's say we had the number 6, and you go, the factors of 6 are 1, 2, 3, and 6, numbers that go into 6. The factors of 6 are not 6, 12, 18. Those are multiples of 6. You want the numbers that can go into 6. So the greatest common factor is the biggest number or biggest factor out of the group. So for 6, the greatest common factor there would be 6, because that's the biggest number that can go into 6. Just remember that variables can be factors too, because they represent numbers, and we're going to get into that a little bit down here. So first, let's look at what are the factors of 24x y to the second. So what you want to do is you want to break down your 24 into the factors. So 24 would give you 1 and 24, 2 and 12, 3 and 8, 4 and 6. And that should be it. Those are all the factors of 24. And then we have a factor of x, and also we have a factor of y or y squared, because y squared can go in that too. So those would be all the factors of 24x y to the second. Let's look at example 2. Now we want to find the greatest common factor of 32xy and then 4x squared y. So let's break down each. So we have 32xy. My factors of 32 are going to be 1 and 32, 2 and 16, 4 and 8, and I think that's it. 4 and 8. Yeah, I think that's it. And then we also have an x and a y in there. Now let's look at 4x squared y. So my factors of 4 are 1 and 4, and then 2 and 2, right? Okay. And then I have an x and also an x squared, and I have a y. Okay, let's look at the greatest common factors that they share in common. So the biggest actual number that they share in common is 4. That's the biggest number that they have the same. So we're going to say 4 is the greatest common factor of the two. And then they share an x and an x, so we can put an x. This one doesn't have an x squared, so we can't put the x squared. But they do share a y and a y. So the greatest common factor, the biggest number that can go into both of these, would be 4xy. Because you'd say, well, what could I multiply 4xy by to give me 32xy? And you would just multiply 8 by that. And then what would I multiply 4xy by to give me 4x squared y? You just multiply x by that, so it becomes x squared. Now let's look at something a little more complicated. So it's asking us to factor this, and it's called an expression, and it's actually a binomial because there's two parts to it. And all you're going to do is you're going to do the opposite of the distributive property. So remember, like if you have 4x minus 2, and you do the distributive property, you're multiplying it, and you get 4x minus 8. Well, we're actually going to go backwards, going this way. So I want to ask myself, what's the biggest number that can go into 3 and 6? So I know 1 and 3 for 3, and then for 6, I know it's 1 and 6, and 2 and 3. So it looks like 3 is the biggest number. So we're going to pull a 3 out. This one has an x squared, but there's no variable here, so we can't put an x here. So I'm going to put a parentheses, and I'm going to ask myself 3 times what gives me 3x squared? And I know 3 times 1 gives me 3, so I could put a 1 if I wanted to, but I have a variable, so I'm not going to. And then 3 times what gives me 3x squared? I'm just going to put an x squared, because 3 times x squared gives me that. Now I want to ask myself 3 times what gives me a positive 6? And I know that's positive 2, so I put a plus 2. This is factored form. So it's the opposite of the distributive property. Now let's look at this one. We have negative 5 and 10. So the biggest number that can go into both of those is 5. We could also do a negative if we wanted to. Doesn't matter. So I'm going to put a 5 on the outside. I have an x here, but I don't have an x there, so I can't pull that out. But I have a y and a y, so I'm going to go like this, y. Parentheses. 5 times what gives me negative 5? Negative 1. Now, I have a y here, but I need xy, so I'm just going to put an x here. So let's go back and check our work. 5y times negative 1x, that would give us negative 5xy. Then I say 5 times what gives me 10? 2. I have a y, and I need a y, so I don't need to put one. So this is factored form, the opposite of the distributive property. The way you could check yourself is to multiply it out again to see if it gives you that. Let's look at this big honkin' one. We have 32, 4, and 8. So the biggest number that can go into all of those is 4. So I'm going to pull a 4 out. Whoops, I don't want to do that. I want to get rid of that parentheses right now. Okay, so let's look at our variables. I have an x squared here, an x squared here, and an x squared here. I can pull out that x squared because it's in all my terms. I have a y squared, but the rest of them are just y's, so I can only pull out a y. So now I go 4 times what gives me 32? 8. X squared times what gives me x squared? Just 1, so I don't need to put that. And y times what gives me y squared? Well, y. Now I need to know 4 times what gives me negative 4, so I know it's a negative 1. I have an x squared and an x squared, so I don't need to put my x squared here. I have a y and a y, I don't need to put my y. Now I'm going to put plus 4 times what gives me 8? 2. Have an x squared and an x squared and a y and a y. Then I could actually simplify this if I really wanted to because I have some like terms. 8y plus 1. Done. Okay, so those are some examples. Tomorrow, or I'm sorry, on Monday, we will work on some more of these together. Have a good night.